Okay, so I'm going to go through and do some just random problems. And I'm not even going to go to the homework assignment. I'm going to go to these practice quizzes. So before we get started with that, let me, let's see here. Let me bring up the factoring steps worksheet one more time. So just to look at this one more time. Organize the polynomial. So most of the time you won't have to do this. Rearrange the terms, just get everything in order, factor out the leading negative sign if that's what there is. Always remember GCF, super important. This is probably the most common mistake on factoring problems. Number one, forgetting to factor out the GCF. So check that first, then work based on the number of terms. 4 terms, factor by grouping. 3 terms, check for perfect square trinomial first. If it's not a perfect square trinomial, go ahead and factor the trinomial using the techniques that we went over, either the quick guess and check or the step-by-step AC method. And if it's just 2 terms, just a binomial, look for one of these 4 special forms. And if it's not one of these, then you probably can't factor it. So you're not going to be able to factor. And then once you've done that, make sure there aren't any more factors that would still factor. And if you can't do anything at that point, by this point, then it's probably prime. You can multiply everything together, so you can FOIL everything out and multiply it out to check, but that's not going to tell you that everything is completely factored. You still have to know that all the factors can't be factored any further. Okay, so let's go to, let me show you. Actually, I'm going to go right back to where I was. So let me show you in the homework here where you can do some quizzes. So these are practice quizzes. These are not part of the grade, but they're very helpful. Let me see if I can actually do this. Okay, so this is PQ28. So before this was homework 43. So this one is an assignment that you do get scored for the grade. But then I have 3 practice quizzes, 28, 29, 30. So there's factoring polynomials easy, and then I have medium and then hard. So you should start with the easy ones, and if you can definitely do these very quickly, move on to the medium ones. And then the last one are just the ones that are really either challenging or not so nice. But work your way up on these. So let's just open up, maybe do a few of these easy ones. I'm not going to spend too much time on the easy ones, probably spend the most time on the medium, and then do a few of the challenging ones as well. Okay, can I open this? Let's see. Start test. These will be completely random. Okay. So here we go. 49y squared plus 25. Okay, I have to make this. Okay, that's a good size. So remember, so first of all, always remember GCF. Now 49 and 25 don't have any common factors, so nothing we can do there. How many terms are there? There's 2 terms. So if there's 2 terms, we're really only looking for those special formulas. We're looking for a sum or difference of squares or cubes. Now 49y squared and 25 are perfect squares. So we have that in our favor. However, it's a sum. So whenever it's a sum of squares, that's not going to factor. So this polynomial is going to be prime. Okay. Okay, actually, I'll give you a moment to pause the video or work on this. I'll do this for all of them. I'll go ahead and just pause for a second, and you can You can pause the Zoom recording and try this out, and then unpause it, and we'll go over it. All right, so this is 3 terms. Now remember, 3 terms, your first instinct is going to be to want to try and do it as these product of 2 binomials. So using the guess and check. You could do that here, but you should always check for perfect square trinomial first. You got x squared, 6 squared, 6x. So does the middle term match 2 times 6x? Yes. So this is a perfect square trinomial. So this is going to be x minus 6 all squared. Okay, I'm just a second. So we're back here. So this is a perfect square trinomial. It's x minus 6 all squared. I guess we go through all of these. Okay, I'll give you a second to do this. This one is probably the simplest maybe in the entire set. All right, so this is just a GCF. There's a factor of 2. So I factor out the 2, y minus 1 left over. Okay, take a look at that. This is a binomial, and it's a difference of 2 squares. 100 is a perfect square. It's 10 squared. So this is z plus 10, z minus 10. Okay. Go ahead and try this one. See whether you think this factors or not. Okay, so here we know, so we could use guess and check because it's just x squared. So we know it's got to be x plus something, x minus something. 51. Now 51 is not prime, but it only factors one way other than 1 and 51. That's 17 and 3. It's a product of 2 primes. And 17 and 3 do have a difference of 14. So this doesn't look like it's going to factor, but actually it does, because I can use plus 17 and minus 3. So x plus 17, x minus 3 actually works here. Okay, here's another guess and check one. Okay, so plus plus, so we're going to get x plus something, x plus something. 19 only factors one way. So there's really only one thing to check here. Just put in 19 and 1 and see that this works. 19 plus 1 makes 20. So this factors as x plus 19, x plus 1. Now let's see here. Oh, okay, so this is just saying, is it in factored form? This is not factored form. This is not factored form. This is not really a factoring problem. It's just saying, is this the right form? With factored form. Okay, so I think they want us to 18x squared y plus 3. Okay, well, let me just copy this. Let's see, it was 18x squared y plus 3. And then plus 5y minus 3. Plus 5y minus 3. Okay, this is not working. Just a minute. Plus 5y minus 3. Now, if these two, if those were actually the same, I could like factor that out, but one of them's positive, the other one's negative. So I just have to distribute this. This is a very strange problem. I don't know why this is, let's see, 30, 24. It's 54x squared plus 5y minus 15. I'm not sure there's really anything here. Maybe this does by grouping. Let's see. If we do these, no, that would give this. Let's rearrange the terms maybe. Maybe if we do 18x squared y plus 5y is 54x squared minus 15. This still is not going to work. This just doesn't work. I'm not sure what the point of this problem is. Let's go back. Okay, so it's not, okay, so there's a part C here. It's not possible to factor. It doesn't factor. It doesn't factor by group. If you multiply it out, there's 4 terms, but it doesn't factor by grouping. Kind of dumb problem, I think. Okay. So take a look at this one. Just a binomial, but it's not a special formula. All right, so notice the minus sign out in front. So we're going to factor out a negative. And then what's the GCF of 14 and 35? Well, that's 7. So we could factor out -7. And we're going to be left with 2x squared minus 5. Right? So if you can distribute this through, you would get minus 14x squared plus 35. So it's just a GCF, just factoring out the GCF of -7. Okay, 2 more. Factor by grouping. This is another weird one. So if you factor by, what they want you to do here, I'll show you. They want you to do factoring by grouping and say, look at the first 2, there's x plus 8. And then from the second 2, I could factor out -8 x plus 8. And this gives me x plus 8, x minus 8. But notice this is a difference of squares. But I could have noticed that at the beginning by noticing that 8x and minus 8x cancel out. So really I just have x squared minus 64. So again, this is kind of a silly problem in my opinion, because the only way that you would get this factoring by grouping is if you're trying to use something like the AC method, but you don't use the AC method on binomial x squared minus 64. So again, kind of a dumb problem, but we can factor it. It's a difference of 2 squares, x plus 8, x minus 8. Okay, and then this one they tell us is a difference of squares. Okay, actually it seems like this one is exactly one we had before. These are random, but sometimes they repeat like this. So, okay, so how do I do this? How do I submit this? Submit. We get 100%. Okay, we got 100%. Great. All right, so let's go on to the medium ones. So these were, now if you notice here, when you do this, there's, videos on some of them or help things. Let's go to the next. Okay, so this one now, these are average. Okay, so I said medium, average. So these will be a little bit harder. So let's start. Okay. So for each of these, I'll pause for just a minute so you can pause the video and look at it. Take as much time as you need, and then we'll go over it. So take a look at this one. So this one, you may be tempted to distribute through, but if you notice there's an 8x plus 3 inside the parentheses there. It's quantity 8x plus 3, and there's also an 8x term and a 3 term. So if you think of the parentheses around the 8x plus 3, this is one of those ones that is not, you don't want to distribute and do factoring by grouping, because in a sense, you've already done a little bit of factoring by grouping. Really, you can factor out 8x plus 3, and you have 4x squared plus 1, because when you put the 8x plus 3 in parentheses, it's really 1 times 8x plus 3. So 4x squared plus 1 is what's left over from that. Okay, hope that makes sense. If it's, go back to the GCF and factoring by grouping video if you're not quite sure exactly what I did here, and that's where we covered it. All right. So take a look at this, and yeah, you probably are going to have to pause for a couple minutes here if you haven't done many of these. It's the sum of two cubes. So this is practicing the sum of two cubes. So take as long as you need, and we'll go over this in just a sec. Okay, so what are the things that are getting cubed to make this? So it's going to be 4x. So 4 cubed is 64. So 4x all cubed is 64x cubed. And 125 is 5 cubed. So it's 5 cubed. So there's my first and last. 4x is the first, 5 is the last. The formula, remember, it's the binomial, you take away the cubes. So it's just 4x plus 5. Same, opposite, where I have to square. So 4x all squared is 16x squared. I change the sign because it's SOAP, same, opposite, always positive. I multiply the 4x and the 5 together, but I don't double it. So it's not like the perfect square trinomial. It's not 2 times first last, it's just first last. So minus 20x plus the last squared, which is 25. So 4x plus 5 times 16x squared minus 20x plus 25. Okay. So try this. I think you could be able to do this by guess and check. It's not too bad. Okay. So we know this is going to be 2x plus something, x plus something. What's going to get filled in here? It's got to be 13 and 1. So there's really only 2 possibilities, 13 and 1 or 1 and 13. 1 and 13 is going to give us 26 and 1. So that can't possibly be right. So the only possible thing it's going to work is if it's 13 and 1. And if you FOIL this out, you do get 13x and 2x, which exactly makes 15x. So we luck out here. So this one, we can use guess and check to see it's 2x plus 13 and x plus 1. All right, go ahead and look at this. Now be very careful on this one. There's actually a couple steps here. So go ahead and factor this and make sure that you've factored it completely. Okay. First thing to notice is don't forget the GCF. There's a -3. So I want to get rid of the negative out in front, and there's a factor of 3. So that'll be -3 times x squared. And when you factor a negative out of positive, it's going to leave a negative. So I got -3 x squared times x squared minus 4. But remember, don't stop there. Just because you do a GCF doesn't mean that you're done. You want to look for what's more. Well, x squared minus 4 is itself a difference of squares. So we continue on. So it's -3 x plus 2 x minus 2. And that is the final factored form. So when I said make sure that you've factored completely, it's not just if you've done the trinomial thing or you've done the difference of squares twice or something like that. It's also that you may have done a GCF. You have to do a GCF, and you also have to factor a trinomial or do a special formula. And this is one of those examples. Okay. So go ahead and try this one out, and we'll go over it in a sec. All right, this is also one that it looks worse than it is. For one thing, it's got X and Y, so that makes it look a little bit more visually intimidating, but the numbers are really 5, 7, and 2. Those are all prime numbers. So really, I know this has got to be 5x plus something, and then x plus something. The only possibilities are 2y and y, or y and 2y, and one of those works and the other one doesn't. So the one that's going to work is 2y and then y, because that's going to give me 5xy and 2xy, which together make the 7xy. So again, don't let the looks of one of these deceive you. Some of the ones that look more intimidating, maybe like this one, are actually you can able to do by guess and check pretty easily, and other ones that maybe don't look as bad, you really want to do the step by step. It just takes experience. All right, factor completely. This is 4 terms. So which technique are we using here? We're going to be factoring by grouping. Okay. So go ahead, pause the video, see if you can factor this by grouping. Second. Yeah. Okay. Okay, so let's do the first 2 terms, which we can factor out an x squared. We're left with x squared plus 7. The next 2, you need to factor out a minus, and there's also a 9x. So minus 9x. And we're also left with x squared plus 7. Yeah, so that should, let's see here. Oh, but now what did I forget to do first? This is a good illustration. So I forgot to do forgot to take my own advice. So stop, pause for a second and think about what did I forget to do at the beginning here? So I did not do the GCF first. There actually is a GCF because all of these, they're x to the 4th, x squared, x cubed, x. Those all have a factor of x. Now I can repair this. So if you forget the GCF, it's not like it's the end of the world if you are really careful. So I could say, well, this is x squared plus 7. And then there's x squared minus 9x. But then I have to be very vigilant and notice, oh, on this x squared minus 9x, that's weird. There's a factor of x there. So it's roaming around there. Annabelle, please. So there's an x factor roaming around there. So now if I recognize it, I can factor it out. So I can say, well, let's take out that x. And get x minus 9. Now I can be done. It's x times x squared plus 7 times x minus 9. Okay, so that's what you should, and you could change the order of the 2 binomials, it doesn't matter. Okay, this is a perfect square trinomial, so go ahead and see if you can get this one. So now this, they tell you it's perfect square trinomial, but you should check. This is going to be x plus 8y all squared. 8y all squared is 64y squared. Now, again, in practice, they're not always going to tell you, oh, this is a perfect square trinomial. Some of these ones here, they do. In general, they might not. Okay, we got another factoring by grouping one, it looks like, because there's 4 terms. So go ahead and try this. Okay, this is one that if you try and do it the order that's given, you're going to run into problems because x cubed minus 2, there's no GCF there. So what you want to do is change the order of the factors. Remember we talked about how sometimes you have to change the order of the factors in factoring by grouping. So I'm just going to switch the 2. Well, yeah, let's just switch the middle 2 terms. So I'm just switching the minus 2 and the 2x cubed y. Okay, so now the first 2 terms I could factor out x cubed, and I've got 1 plus 2y And what do I get from the second two terms? I need to factor out a -2. I guess this would work the other way as well. I take that back. If you group the first and the last term together, it wouldn't work. So now I've got a -2, 1 plus 2y. So altogether, 1 plus 2y. And what's left over is x cubed minus 2. This would work, yeah. If I had not switched the order, it still would have worked. So you did not have to change the order here. Okay. 2 more on this one. All right. So yeah, this one, what are you going to look for first? Coefficients of 8, 24, 40. So those are all divisible by 8. So y squared minus 3y plus 5. So notice that if you really, if you tried to do this by the AC method and you didn't see the GCF, look at how big these numbers are. You'd be saying, well, I'm trying to find two numbers that multiply to 320 and add to 24. That's very bad. So it's really a problem when you forget to do the GCF. Now this y squared minus 3y plus 5, I need two numbers that multiply to 5 and add to 3. That's not possible. So in fact, this is it. I can't do anything more. It does not mean that it's prime. The quadratic is prime, but since I factored out an 8 GCF, the original quadratic is not. So the y squared minus 3y plus 5 is prime, but the original 8y squared minus 24y plus 40, that's not prime. So. And this last one here, this is, what do I want to do with this? What do you think? Got 2763. I think there's a common factor there. There's also a minus. So why don't I take out a minus? And what's the GCF of 27 and 63? I think that's going to be 9. So if we factor out minus 9, 3x squared minus 7. And I think that's all we can do here. Yeah, 3x squared minus 7. It's a binomial. There's nothing special there, so there's nothing we can do with it. So I think that's it. Whoops. Yeah. Okay. So let's see how we did on this one. Submit. What, we missed one. Which one did we miss? Let's see. What do I do here? 4x plus 5. This is a sum of cubes, right? 4x plus 5, 16x squared minus 20x. What is wrong there? Oh, okay. All right, that's not a big deal. I forgot to backspace the, I type in the stuff that I want you to think about, when I'm doing the work. I didn't backspace it out. So we have the correct answer you can see here. So we factored it correctly. Okay. All right, so let's go to, maybe we're not do all of these. Let's just do a couple. These ones are really the ones, if you can do up to the average, you're doing pretty good. Don't sweat too much or stress too much if you have some trouble on some of these ones in the difficult, the hard. Okay, there's a GCF here of x. So let's see. 81x squared plus 18x plus 1. And now you need to recognize this is a perfect square trinomial. All right, it doesn't look like it. It's 9x. That's 9x all squared and then 1 squared. The middle term matches. So this is x times 9x plus 1 all squared. And I will remember not to leave this stuff over here. There we go. So it's that. So it's a GCF followed by a perfect square trinomial formula. Okay, what about this? Well, actually, this is not really, I don't think there's anything complicated going on here. It's just that you have to remember about the GCF and that you take the smallest power of each variable. 6, 9, and 15, those are each divisible by 3, so I can factor out 3. There's an x squared in common. There's a y, so y to the first, and there's a z in common. Remember to always take the smallest power of each of the variables that shows up in all of them. So that case, it's x squared, y, z. Now what's left over? From the first term, I've got a 5. I'm missing x, y squared, just xy squared. From the second one, I'm missing 2. What else do I need? I need a y, and I've already got a z, so I don't need that. Actually, from the first one here, take this back. Eyes can glaze over with all these x, y's, and z's. Let's see, 15, x cubed, y cubed, z cubed. I need another z squared here. So always double check your work. 15, x cubed, y cubed, z cubed. Okay. Then plus 2, x squared, y. Okay, so I need a y, and I do not need a z. So just 2y, right? 6, x squared, y squared, z. And then what's left over from the last one? 3, I'm missing a z, so plus 3z. Yeah, you can always distribute through, you can always multiply out to check. And there's nothing I can do. This trinomial is not anything like we've seen, so it's just a GCF. Okay, this one is probably one that you want to do guess, you want to do AC method. Let's see here. Yeah, so go ahead and pause the video so you can do this AC method. Okay, so you should have gotten that this was let's see. See if I can do this by guess and check. Minus 2y minus 3y. Yeah. So you should have gotten, so you're looking for two numbers that would multiply to 36 and have a sum of 13, add to 13. And that's going to be 4 and 9. So 9 and 4, you'd break up this middle term as minus 9xy minus 4xy. And after you do the factoring by grouping, you should have gotten 3x minus 2y times 2x minus 3y, which you can multiply out and see that that's what we get. Okay, so this is one of those trinomial ones that you don't want to do guess and check. You really need to know the step-by-step. Factor by grouping. Okay, this actually doesn't look too bad. So from the first two, I can take out x squared. (5x minus 3). The second two, I could factor out a negative 3. And I'm also left with 5x minus 3. So altogether, 5x minus 3, x squared minus 3. Oops, x squared minus 3. So actually this one, I mean, it's in the hard section, but this is really just a pretty standard factoring by grouping. You just have to be careful. Okay, this one. So this one's a little tricky. So this is an idea, substitution. So let me go over this. 3 minus 11 minus 4. Okay, so this was 3 minus 11x squared minus 4x to the fourth. So the problem here is, Well, there's a number of things. If we rewrite the order of the terms, it's minus 4x to the fourth minus 11x squared plus 3. We want to factor out a minus, which would then be 4x to the fourth plus 11x squared minus 3. Okay, so that's not a big deal so far. But notice now, this looks different than anything we've seen because it's got this x to the fourth and squared. So what do we do with here? So if you notice that x to the fourth is really x squared squared. So we can use something that's called a change of variables or substitution. This is a really important idea. It's not just in factoring, but in math in general. So we're going to let's let u, or let me do let w equal x squared. And the idea is if I let w equal x squared, then the thing I have to factor is no longer this, it's minus 4w squared, because w squared is going to be x to the fourth, because it's x squared squared. So it's 4w squared plus 11w minus 3. We would say that this is quadratic in x squared. Now, does this factor? Yes, it factors as 4w, w, 3, 1 plus minus. So it factors as 4w minus 1, w plus 3. But then I need to go in and replace the w with x squared. So this is going to be x squared. This is going to be x squared. So in the end, I'm left with, running out of room here, but it's minus 4x squared minus 1, x squared plus 3. And now we have additional problem. So this is probably the worst one so far. Now we've got the 4x squared minus, let me copy this over here. So far we've got minus 4x squared minus 1, x squared plus 3. Now you have to recognize that this is a difference of squares. It factors as 2x plus 1, 2x minus 1. So altogether, it looks like we get minus 2x plus 1, 2x minus 1, x squared plus 3. Okay, so there's a lot involved in this one. Let's go back. We had to rearrange the order of terms. So it was step 0. We had to rearrange the order of terms and factor out the negative. Normally, we don't have to do that. Then there was the idea of this change of variables or substitution, recognizing that x to the fourth is really x squared squared. So if we change into w, then we can factor that. You have to put back in x squared for w when you're done with that. You have to do guess and check. And after all of that, you still have to remember to see that, oh, the 4x squared minus 1, that's a difference of squares. So I need to make sure that I don't forget that. So there was a lot involved in this one. And maybe this is maybe a good one to stop at, because we don't need to do all the hard ones here. So it was minus 2x plus 1, 2x minus 1, x cubed plus 3. Okay, yeah, let's just look at the next one here is a difference of cubes. So you would do this like we did difference of cubes. Let's see. Yeah, I know I haven't finished it. I've not completed my assignment. Okay, so we got these first 5. So the 5 that we did, we got right. If you look at some of these other ones. Okay, so that was kind of a standard GCF one. That one wasn't too bad. All right, this one was a little bit weird. You would factor out, you had to do the GCF, you had to factor out GCF of x squared and then recognize it as a sum of squares, sum of cubes. This would be an interesting, you should think about this one. Okay, that's not just messy. Yeah. And that's, okay, so that's one of the ones that's actually difference of fourth powers. So again, if you don't get all these ones on the hard, I wouldn't worry too much about it. If you can, you need to do all the easy and average. You need to be super solid on, and try and do as many of the hard as you can. But if you don't get all of them, don't stress too much. So Yeah, so basically the exam is just factoring. It's just going to be, here's a polynomial, factor it. What's the factoring of it? Factoring is super important in everything you're going to do if you go into intermediate algebra, pre-calculus, anything else after this. So it's definitely something you need to know.